All right, we are picking up on chapter 5, and now we are going to be looking at some different variables that we're going to look for. Okay, so this says to assume that we borrow $700 from a friend. I love to come over here in the margin and start writing things down. That helps me get straight the information that I need and what's put in my calculator. So that's $700. That is the present value. Okay. And they said, we assume that you borrow $700 from a friend and you intend to repay them the amount in four equal annual installments beginning 1 year from today. Your friend wishes to be reimbursed for the time value of money at 8%. So our interest rate is going to be 8%. What is the required annual payment that must be made, the annuity amount to repay the loan in 4 years. So our N will be 4 years. Okay, so we have all the information we need. We would be using the present value of an ordinary annuity. And we would be, let's see here, present value of an ordinary annuity right here. And we were looking at 8% in 4 periods. So we will find where that intersects right there at 3.312213. Okay, so go back over here. We've got that factor, and there is the factor. So we're sort of doing this just a little bit differently because before we would take, the payment and multiply it times the factor, but here we're looking for the payment, so we are going to divide the 700, divide it by that 3.3123 to get the annual payment of 211.34. And I'm going to come over here really quick and we're going to do it on my calculator. And let's go up. Our N is going to be 4 because it was 4 periods. And our interest rate is 8. We don't know, we do know the present value. I was about to say we don't know the present value, but we do know. Okay, we're going to zero out that payment, zero out the future value, come back up here to the payment, hit alpha, enter, and I didn't do it right. Alpha, enter, which did not do this correctly. So N is 4. What did I do wrong? Oh, I see what it is. I have the beginning selected, not the ending. Okay, because it's ordinary. Ordinary is the payments at the end of the period. So I'm going to zero that out again. And there we go. Let's make this go away. Okay. And let's see. We're going to hit alpha, enter, and there we go. We have 211 and 34 cents. Okay, so let's go back over to OneNote. We're done with that one. Now we are going to be looking at finding the number of periods. Okay, so we are going to do, let's see. What are they doing here? So they said to determine the periods when other variables are unknown. Okay. So our present value is still 700. Okay. We don't know what the N is. Okay. That's our question mark. I like putting a little blank because then I can come back and put it there. So let's put a little blank there. Our interest rate is 7%. And they want us to find, we have our payment. Let's not forget that. We have our payment is $100. Okay. So how many years is it going to take us? So we can divide this out and we're going to get the factor 7.0 and we'll go over there to we're looking for the number of periods. What is our interest rate? Our interest rate was 7% right there. So we're going to come all the way down. It looks like we are the closest to 7.2358, which would be 10 years. Okay, let's go put it in the calculator. You're going to get a more precise number with the calculator. So we're going to zero that out. Interest rate is 7. Present value is still 700. We're going to put $100. Let's put a negative there because money's coming in, we're going out. It wants to have one of those as a negative, and I'm trying to get that 7 fixed. Okay, so now we'll do alpha enter, and we have really close to 10 years. Okay, we knew it wasn't going to be perfect because we didn't find a perfect 7 on there. It was a little bit less than 10, which works out to be perfect for this problem. Okay. So, moving right along, we have another one that we're going to do. Okay. Now, we're going to say, suppose a friend, hang on just a second, because this is one I do not want to do. I tried working it before I started recording this video. I was like, we're not going to waste our time on that. So, we're going to come down here and I'm skipping all of those slides that had to do with that one problem. Okay. All right. Here is the real reason why we learn about time value of money because we are trying to value long-term bonds. And at this point, we are almost at the exact same point as financial management. I try to do that so that there's some overlap and it kind of helps the intermediate accounting majors out just a little bit. Okay. So they give us a lot of information here. Get your blurb of information over here so that you can calculate what they want. Okay. We're going to do it on the calculator. We can do it with the tables, but we'll also do it on the calculator. All right. So they said 10% stated rate bonds. So stated rate is 10%. They have a face amount of 200. Okay. Face is sometimes called par value, numbers like that. That's a lot of zeros. Okay. Come back. Our face is 200 million. Can you imagine paying the interest on that? It happens to be 10 billion. It's 10 million. Okay. All right. Face, that's actually going to be our future value as well, because we are trying to calculate two different streams of cash flows. Okay. So our future value will be the 200 million. Okay. Says the bonds mature in 20 years. Okay. The market rate of interest is 12%. So right here, you can compare your market and stated rate, and you know for sure it's going to be issued at a discount because our bonds are not paying as much as everybody else's bonds. Nobody wants our bonds. So we have to price our bonds to yield the 12%. And we can see their calculation already down here, and we know that it's going to be less. You didn't have to have that. There might be a test question that says, hey, if the market rate's 12, stated rate 10, is this a bond at a discount, premium, or at face? It's a discount. Okay. They also tell us that interest is paid semi-annual interest, and or they can say 5%. We'll come back to that in just a second. And said the interest payment, they told us what the interest payment is, 10 million. What is the price of the bond issue and what amount of interest expense will Fumatsu record for the bonds in 2027? Okay. So you've got two strings of cash flows going on here. Okay. The first one is we're going to do the present value of $1. Okay. That's the 200 million. I'm going to abbreviate 200 million from today. until 20 years, what is the present value of just that one string of cash flows? The other is the interest payment. So that is present value of an ordinary annuity. Okay. And that will be the payment of 10 million. Let's put some things in our calculator really quick. Okay. I'm actually going to pull up the regular Windows calculator to do the interest payment. Okay. So this is what gets people really confused on bonds is because what interest rate are we using? Okay. What's printed on the bond is the stated rate. Okay. So to calculate our interest payment, we're going to put 200 million in here and we're going to multiply that times the stated rate of 0.10. Okay. That's 20 millions. These are annual amounts, okay? Annual amounts on these interest rates, but they're paying semi-annual interest, okay? So they're not going to pay 20 million out. They're going to pay 10 million out every 6 months, okay? So my N will be equal to 20 years multiplied times 2, 40 periods. And then my interest rate, we're going to use the market rate, is going to be 12% divided by 2. Okay. So instead of having 20 periods with 12%, we have 40 periods with 6%. Because remember that compounding, it makes that interest go higher. Okay. So we're going to use the 40 and the 6% to figure out both of those. Okay, so let's jump over here to our calculator and let's put in 40 for a period, 6. You can actually, this is kind of one of those little shortcuts. If you didn't do the math already, you could put 12 in there and divide it by 2, and it'll calculate it for you. Okay. We don't know the present value. That is what we are trying to look up. Okay. We're going to put the payment of 10 million. Okay. And let's find the present value of just the payments of 10 million every 6 months. So we'll do alpha, enter, 150,000, long number there. I'm hoping it is the same number as this one. This number, our number on the calculator is probably more accurate because it goes out more decimal places. Look, this only goes out so many decimal places, so those last three numbers are probably not correct. Our number's probably better. Okay, so that is the present value of $10 million paid out every 6 months, 40 periods, 6%, or 20 years at 12%. Okay, so there's that string of cash flows. Okay, let's do the other one. Okay, we're going to zero out our present value, zero out our payment. We're going to go to future value and we're going to put our 200 million in there. Make sure I get the right amount of zeros. 2, 3, 1, 2, 3. Okay, so this is just 2 million. It's going to be paid out 40 periods from now at 6%. So we're going to come up here and calculate the present value. Big number there. Let's go over here. Is that similar? That looks really close to what they did here, but remember they used the tables. Our number is better. Okay. So now let me show you how to do all this in one calculation. Okay. So we can go ahead and put our payment, 10 million. Let's come down here and make sure we put our negative in for future value. You got to do that or the present value won't calculate right. Okay. Now we're going to go up here and hit alpha, enter, and 169,000. There it is, all in one calculation. Okay. I just want you to understand there are two cash flows here. One is the present value of 200 million going to be paid out at the end of 20 years. The other is the 10 million being paid every 6 months. Okay. All right, so let's move on. We're going to look at valuing a long-term lease. Okay, long-term leases are annuities, just like interest payments are annuities. Okay, so let's come down here. And January 1st, the shoe company signed a 25-year lease, 25 years for an office building. Terms of the lease call for annual lease payments of $10,000. So my payment is 10,000 at the beginning of the year. So what does that tell us? Beginning of the year means it's an annuity due. Okay. The first payment due on January 1st, 2027, assuming the interest rate is 10%. 10% properly reflects the time value of money in this situation. How should the company value the asset acquired and the corresponding lease liability? Okay, so we have to do our calculation first. They did not tell us anything about um, semi-annual interest. We're just going to assume annual since they didn't tell us anything. Okay, so we can go over here and put this in our calculator. So we'll go up here and we'll do 25. Interest rate is 10. We're going to zero out that present value. The payment will be 10,000. I'm going to zero out that future value. So now I want to calculate the present value. So we'll hit alpha, enter, and that will be not the number that they got. What did I do wrong? I did not hit beginning of the period. I was doing it as an ordinary annuity. So let's zero that out and let's try it again. There we go. We got the same number that they did. Okay. So what does this mean? Okay. We can't just take $10,000 and multiply it times 25 years and value the asset. Okay. Because there is interest to this. The asset is not worth, not necessarily worth 250,000, which is the total of all the payments over the life of the lease. The present value of this is 99,847. Everything else will be interest. So we record this in our journal, right to use 99,847, lease payable 99,847. When they make that $10,000 payment, part of that will be principal, part of that will be interest. Okay. All right. I'm not going to skip over that one. Okay. We're getting really close to being done, y'all. All right, so let's do this valuation of installment notes. So we have January 1st, 2027. The shoe company purchased $35,000 machine with a down payment of $5,000, a 5-year installment. I hate it when it does that. There we go. 5-year installment note for the remaining 30,000. Terms of the note call for an annual installment payments at the beginning with the first payment due January 1st, 2027. Okay. And then at each December 31st thereafter, assuming a rate of 4%, what is the amount of the annual installment payments? Okay. So our present value is 30,000. They try to trick you with these little numbers up here and that. We really don't care about that. The present value right now is 30,000. Okay. Our interest rate is 4%. And how many years was this? 5 years. Okay. They want you to calculate the payment. Okay. We could go and look for the factor, but let's go put it in our calculator. Okay. So Let's go up. Number of periods is 5. Interest rate was 4. Present value is 30,000. We're going to zero out that payment. We are looking for the payment, so we wanted to make sure we zero that out. Hit alpha, enter. We get a payment of 64.79. That is really close to what they have, just a little tiny bit off. Okay, so that is the payment that will be made every year at the beginning of the period, 64.80. Okay. So on the journal entry to make that would be to debit the machine for 35,000. So you needed the 35,000 to calculate to be able to know what to journalize and record that machine at. So it wasn't useless information. If they didn't ask us to make this journal entry, we wouldn't have needed it. Credit cash, credit notes payable. And then the very first entry, they will debit notes payable, credit cash. There's no interest on this one because it was paid right there at the beginning. Okay. So they went ahead and they went into the next journal entry, and how you would calculate that, they had $30,000 note. They made that first payment at 6,480. So that leaves us, they did not do that math. They didn't put that number there. So 30,000, oops, one too many zeros, minus 6,480 gives us 23,520. And we can multiply that times the 4%. That is our interest for the next period. The payment will be the same, but $940.80, they rounded it to 941, which makes sense. All right. So the interest expense is 941. The difference between the payment, the 64.80 minus the 941, gives us 55.39. That is being debited to that notes payable because it's bringing that notes payable down. Okay. I am not going to do pensions. I'm not going to make you suffer through the pensions. We've got a whole chapter in Intermediate 2 to do that. Here are some really good slides that kind of go into doing all this time value of money in Excel, which we did in financial management. But if you're not in financial management right now and you want to try this, please feel free to do that. It's a very good skill to know how to do all of this in Excel. Okay. All right. And we are done with chapter 5. I will see you in chapter 6.